In the movie The Martian, a hurricane-force dust storm rips an antenna out of the ground and hurls an astronaut across the surface, stranding him alone on a dead planet. It's one of the most famous scenes in space cinema, and it's completely wrong. If you stood in the strongest storm Mars has ever produced, you wouldn't be knocked over. You'd barely feel a breeze. So what actually happens when the entire sky of another planet turns to dust? That's what we're breaking down today. Here's the trick. Mars does get real windstorms, with gusts up to 60 miles an hour. That sounds violent, but Mars' atmosphere is less than 1% as dense as Earth's. Wind force depends on both speed and density. So a 60-mile-an-hour gust on Mars carries roughly the same punch as a 6-mile-an-hour breeze here on Earth. NASA scientists who studied this said it plainly. In a Martian dust storm, you'd probably feel a breeze, but it wouldn't knock you over, and it couldn't rip apart mission hardware. So if the wind is that weak, why is dust on Mars a real danger at all? Because the threat was never the wind. It's what the wind carries and how far that dust can spread. On May 30th, 2018, NASA's Mars Reconnaissance Orbiter spotted a small dust cloud forming in the northern hemisphere. Within 2 weeks, it had swallowed a quarter of the planet. By June 19th, it was officially declared a planet-encircling dust event, the first global storm since 2007. The sky didn't just get hazy. Optical depth, a measure of how much sunlight gets blocked, hit values 10 times higher than anything ever recorded on Mars. In places, it was like standing under a thick fog that never lifted day after day for months. For NASA's solar-powered Opportunity rover, this was fatal. 14 years of exploration ended in silence. Its last transmission came on June 10th, 2018, a battery running critically low, a storm still growing. NASA never heard from it again. Curiosity survived. Its nuclear power source didn't care whether the sun was visible. But even Curiosity's cameras captured something unsettling, a slow fade to darkness. Images taken days apart showing the same crater wall disappearing behind a wall of ochre haze. Here's where it gets strange. Inside these storms, scientists discovered something they called dust towers, concentrated columns of dust that heat up in sunlight and rise. During the 2018 storm, some towers climbed to 50 miles high. That's wide enough at its base to cover the entire state of Nevada. And these towers might explain one of Mars' oldest mysteries. Where did all its water go? Researchers think dust towers act like an elevator. Water vapor rides the rising dust up into the thin outer atmosphere, where solar radiation tears the molecules apart and lets the hydrogen escape into space permanently. Billions of years of storms like this one may be a major reason Mars went from a wetter, warmer world to the frozen desert we see today. A weather event isn't just weather here. It's slowly erasing the planet's water, one storm at a time. So if the wind can't hurt you, what's the actual risk for the humans Mars agencies hope to send in the coming decades? 2 things. First, darkness. A months-long storm can choke out enough sunlight to starve solar-powered habitats and equipment. Exactly what killed Opportunity. Any future Mars base leaning on solar power needs a serious backup plan or nuclear power. Second, the dust itself. Martian dust grains are extremely fine and mildly electrostatic. They cling to surfaces like packing peanuts and get into every seal, gear, and joint. Engineers already lose sleep over keeping solar panels, camera lenses, and airlocks clean on a planet where the wind that stirs the dust is also too weak to blow it back off. There's even evidence dust devils generate their own electric fields, which could mean arcing, static discharge, and interference with radio equipment for future crews. Nothing here is a Hollywood catastrophe. It's slower, quieter, and in some ways more dangerous. An entire mission's power and hardware degraded gradually, storm after storm. Mars doesn't need hurricane winds to be one of the most hostile places we've ever tried to explore. It just needs patience. The slow, grinding kind that killed a rover reshaped a planet's water history and will shape every habitat we ever build there. If you want to see how humans might actually engineer around threats like this, subscribe. We're going deeper into the future of Mars exploration next.